Hey guys, it's John from Owl Test Prep with another problem of the day. This is problem of the day number 2. So we got a geometry problem, triangles and circles. So if the area of the circle inscribed in triangle ABC is 16 pi, what is the area of triangle ABC? So take a second, pause the video, give it a shot, and when you're ready, go ahead and press play and we'll go through the solution together. Okay, so hopefully you gave it your best shot. Let's see whether you got the correct answer. So it's a PS problem, and one of the things I always do with PS problems is I always scan my answers just to see, like, are there any outliers? How far apart are they? Maybe I can estimate. So the answers are pretty close together, and I'm told that the figure is not drawn to scale. Oh no. So generally in PS problems, figures are drawn to scale, and you can use some educated guessing, some estimation, especially if your answers are pretty far apart, to at least narrow down your answer choices. Now in DS problems, or data sufficiency problems, the figures are never drawn to scale, or they are drawn deceptively to scale. But here, obviously, somehow 14 is shorter than 13, and the diagram's kind of wonky, thanks in part to my lack of artistic and architectural skill, but we'll just move on from that. So one surefire thing you can always do when you see a circle is to insert a radius. And lines that are tangent to circles, for instance, in this case, the sides of the triangle, are actually perpendicular to the radius. So like if I insert the radius this way, I get a nice right angle for free. So maybe that'll be helpful. Now I'm told that the area of the circle is 16 pi. So hold on a second. My keyboard is still attached to my tablet. Okay, problem solved. And a cat is invading my desk space. Okay, that problem has now been solved as well. Anyway, so area of the circle, I'll just put a little circle there to stand for circle, is 16 pi. And I know that the area of a circle is pi r squared, so that's also 16 pi in this case. And if I cancel the pi's, r squared is 16, so r must be 4. Okay, so this guy's 4. Sweet. Now what? What can I do with that? Well, as often is the case in geometry problems, it's useful to stick in some extra lines. And so I'm gonna draw a new triangle by connecting the center of the circle, which I guess I'll call O. Let's put the O right there, to A and B. And now I've got this new triangle, right? Right here. And so what's the area of that triangle? Well, since the radius is perpendicular to the side AB, I could treat 15 as the base and 4 as the height of that triangle. So let's do that. Let's see. So triangle ABO. The area would be 1/2 base times height. And in this case, that's 1/2 times 15 times 4. So 1/2 times 60, and that's 30. Okay, sweet. And, well, this gives me an idea. Now I'm feeling creative. So if you've got this far and you want to try and finish up the problem, I suggest you pause the video again and give it a shot. Okay, so hopefully you're back and you've figured it all out and you've found the correct answer. So I'm just going to continue with the same process. I'm going to draw radii that are perpendicular to the sides. And I'm going to use those lines to be the altitudes of triangles that I get when I connect the center to the vertices. So I've got, let's see, Maybe I have a different color. Do I have a different color? I'm not going to mess with that. I'm just going to leave it so that here's a base, right? And the height is the same, and here's another base, and the height is the same. So this triangle AOC, is also going to be 1/2 base times height, but in this case that's 1/2 times 13 times 4, and that's 26. And then the third triangle, let's see, BOC, it's also 1/2 base times height, and in that case it's going to be 1/2 14 times 4, and that's going to be 28. Okay, so we've decomposed our big triangle ABC into 3 smaller triangles where the height and the base are more obvious, and we just add these guys up. So that's 14, carry the 1, and I get 84. So E, 84 is the correct answer. Okay, for all you formula freaks and math wizards out there, the shortcut to this is we have area equals S and then R. So S is the semi-perimeter, and this is totally outside the scope of regular GMAT sort of thinking, but I'm such a nerd that I can't resist. And then the radius is the radius of the in circle. So that's the inscribed circle. So in this case, if we do that, that's 15, 14, 13, 27, 37, and 42. So we get 21 times 4. Okay, 84. There, I'm done nerding out. So what are the takeaways? The takeaways are scan your answers in every PS problem. Make sure you pay attention to whether the figure is drawn or not drawn to scale. Figures that are not drawn to scale are actually kind of unusual. There are only maybe 3 of them in the 2018 official guide, and I think there are only 2 in the 2019, so it's not something that comes up a lot, but it's something you need to be aware of. Radii are perpendicular to tangent lines. That's good. You should always insert a radius. It's never going to hurt. And be careful about the radius that you choose to insert. Don't just randomly insert it. See if you can connect it to something or create a new figure. And don't be afraid to insert lines to decompose complex figures into simpler figures. And of course, most important of all, don't forget to subscribe and keep coming back for more problems of the day. Thanks a lot, and I hope you enjoyed it.